good. So weather occurs over a short period of time. What's the difference with climate? Demetrius, do you see like you really want to answer? Go ahead.
Climate is temperature, humidity, air pressure, heat, clouded over.
Decades? Is that what you're trying to say? Do you remember what decades mean? What is a decade? Yeah, years. Okay, so Andrea said weather is a short period of time. Demetrius said climate is over decades. So who can put all that together and give us the difference between climate and weather? Only one person? I'll wait for a few more hands to go up. Saw a lot of people writing this down in the beginning of class. Chrissy? Good. Weather occurs over a short period of time. Climate is something that occurs over decades. It's the average. So remember, when we looked at our pictures yesterday, we were looking at weather, but the climate in the place might have been completely different than the weather. So, who can read this quote out for us nice and loud? Diana?
Weather is what you wear each day. Climate is what is in your closet.
Okay, so weather is what you wear each day. Climate is what's in your closet. Does this make sense? Or does this not make sense?
Makes sense.
If we think about our definition of climate and weather, does this make sense? Vanessa, what do you think?
I think it makes sense.
Can you explain why, please?
Because if it's warm outside, then you wear warm clothes. But in the winter, you have all these jackets stored so that you won't be cold.
Okay. But people who live in Phoenix, let's say you lived in Phoenix, are you going to have a lot of heavy coats for the winter?
Not really.
But I used to live in Pittsburgh, right? Where it snowed in the winter. Do you think my closet looks a little different now than it did in Pittsburgh? A lot different, right? I had a bunch of heavy coats, a bunch of hats put over my ears, a bunch of scarves, right? So my closet, because I was in a different climate, was a lot different. Now my closet, I think it's better. I got shorts, I got a few light jackets, and that's about it. Question?
This you got a hat that has like little strings in it. Like it looks like a beanie, but it has strings in it.
Oh, okay. So you think I'm like some snowman builder, lumberjack guy?
Yeah.
Okay. I did not have that, but alright, so we got a lot of objectives today. So we need to be working hard. We got a lot to get through. So we're going to develop predictions and hypotheses about temperature variations in Earth's climate. We're going to test our hypotheses through an experiment. We will define keywords that will help us analyze how location affects climate. And at the end, we will be able to explain how latitude affects climate zones. Okay? So everybody, make sure you got that worksheet in front of you. First, just a quick pair share. Turn to your partners. Describe the weather in these different times of the year. What's the weather like in Phoenix? In Glendale? Turn to your partners. Take 1 minute and 20 seconds. Person A, B, and C. Go. Person A, go first. Compared to July and August, January quarter or July and November. Really hot, okay. have these differences in temperature? What do you guys say? Alright guys, good job. Everybody's working hard. Last point. Give me 5. Alright, so somebody describe the weather that's going to be coming in 2 months in January. What's the weather like in Glendale, Phoenix in January? We all live here, so I'm not even going to take any hands because everybody can answer this question. Alexis, what's the weather like in January? It's cold. Good. And who can describe the weather in July? Again, I'm not taking hands. We all live here. We all can answer these questions. Johnny, what's the weather like in July? Can you give a complete sentence, please? It's hot, right? It's really hot. Good. And you can describe the weather in November. Myra, what's the weather like in November? Cold? Is it as cold as January? Is it colder than July? Yeah. Okay, so it's kind of in between January and July. Good. Okay. So, let's come up with some ideas. So we just talked about 3 different months. Why do we have these 3? Why do we have 4 seasons? I could have put in an extra month and we could have talked about all the seasons. But why do we have these differences in temperatures during these seasons? Damien, what do you think?
Like where the sun's at in the Earth's orbit? It depends where it's at.
So where the sun's at. So you're telling me the Earth orbits and the sun's moving too? Where the sun's at in our orbit?
The Earth's at in the orbit.
Okay, so maybe where the Earth is at in the orbit. Good. So we'll write that down. So I'm just going to put an E for Earth. Earth's position in orbit. What else? Maurice?
Earth's axis.
Earth's axis. What do you mean by that?
Like the Earth planet has an axis. Where the weather of the southern hemisphere, some of that moves back to the equator.
Awesome. So, Earth's axis. What Maurice is talking about is the Earth is tilted at a 23.5-degree angle. So if you look at this globe over here, we see that our Earth is not straight up and down, right? If it was straight up and down, it would be like that. But what Maurice is talking about is the Earth is tilted a little bit. Okay? So because the Earth is tilted, this is going to cause us to get different seasons and different heating. So this is what our job is going to be today. We're going to see how, depending on your location on the globe, we're going to see how it's going to change your climate. So if somebody would like to read, you can either read off your lap sheet, or you can read off the board. Somebody read what we're doing with this differential heating lab. Esperanza, nice and loud for the class, please.
In this lab activity, your group will be using a sun-Earth model to investigate the differences in how much our sun heats Earth and at various altitudes.
Look at that word again.
Oh, that's
Good.
your teacher will demonstrate before you begin the make some predictions and hypotheses about Earth's temperature.
Okay, good. So if everybody looks over here. On this model of the Earth, you see these wires coming off the Earth. What these wires are they are what's called temperature probes. Okay? So they're giving temperatures of different locations on the Earth. So I'm giving you 3 different locations that you need to hypothesize about. And you're going to write these down on your sheet. So, one location is at what we call Phoenix, Arizona, where we live on the globe. That is at 33 degrees north. Okay? So I'll write that on the board. Probe 1. (33 degrees north), and that's Phoenix. Probe 2. It's at 0 degrees north and south. That's the equator. Okay, so if we look over here, right in the center of the Earth, we have our probe. It's the equator. And all the way down at the bottom, in the South Pacific Ocean, we have probe 3. Probe 3 is at 40. Oops. Let me double check that. I think it's 45 actually. 45 degrees south, I think. Yep. So probe 3 is at 45 degrees south. Okay. So that's in the South Pacific. What I want you to do now is your tables. We just talked about the Earth's tilt, how we have different seasons. For 1 and 2, it says predict where you think it'll be hottest and explain why you chose that. So to do that, you're just going to write an if then because statement, which we know is a hypothesis. We practiced this last week. For number 2, predict where you think it will be coldest on the Earth's surface and explain why. So your predictions are going to say, you're going to be talking about probe 1, 2, or 3. Okay? So think about this light bulb is going to be turned on, that's the sun. Think about which one's going to be the coldest, which one's going to be the hottest out of these 3. You guys can talk with your partners, make some predictions on 1 and 2. I'll give you 4.5 minutes to write down your predictions. Your time starts. Closer to the sun, or they all look like the same distance? What's the difference between the one at the equator and the one below? It's going to be the hottest when that light gets turned on. Okay, which probe will be the hottest? Louise, which probe do you think is going to be the hottest?
I think that the equator is going to be the hottest
Because what?
because when you turn it on, it hits the equator more.
Okay, hit the equator more. The light hit the equator more. Good. And so just listen to what Louise said. It's going to hit the equator more. So we'll see if that happens. All right. I saw a lot of other people had that written down as well. Esperanza, can you share out what do you think will be the coldest probe?
I think that the coldest will be the South Pacific Ocean because it's at the bottom and it hardly gets sun on it.
Good. So she's making her prediction on. If we look at the globe right here, if you look at my finger, this probe is all the way at the bottom. So she thinks that's going to be the coldest because it's not going to be getting as much light. Right? So what we're going to be doing is over the next 20 minutes, we're going to be checking temperatures throughout the lesson. So every 5 minutes, we're going to go over and check the temperature. Okay? So what you need to do is thermometer number 1, you need to write 33 degrees north. So look at your tables, there's little blank spaces there. You need to fill in what latitude, which we're going to go over what that means, what latitude it's at. So thermometer 1, or probe 1, is at 33 degrees north. Thermometer 2, the one in the middle, is at 0 degrees north and south, that's at the equator. And thermometer number 3 is at 45 degrees south. So just to check with you, I'll let you know what the temperatures are starting off at right now without the sun on. Okay, our temperatures. Probe number 1 on top is at 22.8 degrees Celsius. Temperature at the equator, 0 degrees, is at 23 degrees Celsius. And the one at 45 degrees south of the equator is 23. So they're all, and this one on top is getting to about 23 now too. So they're all pretty much the same. They're all about the same, okay? So, what we're going to do while this is happening is we're going to learn these 4 vocabulary words. So, when this is over, you're going to use your vocabulary words to explain how the different locations affect climate, okay? While we're doing this, if everybody would flip to the back of their worksheets, you're going to be flipping back and forth. You see that we're going to define each vocabulary word, and you're going to draw a little picture. So each of these vocabulary words will take us about 5 minutes, and then we'll check our temperature, okay? So, are you guys ready?
Yeah.
All right. When somebody tells me to go, I will turn my stopwatch on and flip the switch.
Go.
Okay, let me get that center. So now, Myra, you come up here for a second and at least tell us that this is giving off some heat like the sun, just so people believe. Feel that? Some heat? Okay. All right, so we're going to define some of these words so we have a better understanding, and so when we explain if our predictions are correct or incorrect, we can use good scientific language. So, our first word is latitude. Everybody say that. Latitude.
Latitude.
Good. Okay? So make sure we're writing this down. Whatever's in red, you're writing. I should not see your pencils stopping. So latitude is the measure of how far north or south of the equator a location is on Earth. So you heard me talking about that Phoenix is 33 degrees north. The equator was 0 degrees north and south. And in the South Pacific Ocean, we were 45 degrees south. That's the latitude lines. So if you look at this picture, the horizontal lines, that is lines of latitude. Okay? I want everybody to just raise their arms out like this. Okay? You see how this resembles these two T's? The top of the T is your head, and when you cross your T, that's you putting your arms out. And this is horizontal, right? Just like the lines of latitude. Okay? So that's why latitude is the horizontal. It's an easy way for you to remember that it's the horizontal lines. Another way you remember, that I remember at least, I like to go to the gym, right? I've mentioned that a few times. I like to work out. These muscles right here on your sides, when you raise your arms up, these are called your latimus dorsi. So you see how it's lat in there? Because when I do it, it helps me move my arms kind of up and down, just like our lines of latitude go up and down. Okay? So when I'm saying that Phoenix is 33 degrees north, I'm saying that its line of latitude, its horizontal line on the globe, is 33 degrees north of 0, which is our equator. We'll go over that word next. So make sure you're drawing your little picture down. And we'll be checking our temperature in about 2 minutes. So again, each of these different temperature gauges, these probes, they're all at different lines of latitude. Okay? So when you're talking about your explanation later, instead of just saying Phoenix is at 33 degrees north, you might want to say something like Phoenix latitude is at 33 degrees north. Okay? It'll make you sound a lot more scientific. People will believe your explanations and your results from your experiments.
I'm sure you're drawing some sort of lines to show you lines connected with it.
And just to be clear, if you go out to space and look at the Earth, you can't actually see these lines. Okay? There's not actually lines drawn on the Earth. It's just something that we have developed over the years, so we can use GPS systems. So we know where locations are out on Earth. So if somebody gets lost, or if we need to find a location, we simply look at a line of latitude. And then we have to look at another line of longitude, but we're not going to look at longitude lines right now. Just focusing on latitude. Okay, so if everybody flips back to the front of their paper, we're about to put down our first set of data. So can I get a volunteer up here to come read what our probes say, and I'll fill it in on the board. So, this is our first 5 minutes. Diana, can you come on up, please, and read to us the temperature in Celsius. Read it nice and loud, and then I'll fill it out on the board as you're reading it. This is temperature 1. This is 1, 2, and 3. Okay. So, Diana, what does thermometer 1 read? Okay, so everybody, 25.8 Celsius. What does thermometer 2 say?
Thermometer 2 says 34.8.
Say that again?
34.9.
34.9 degrees Celsius. Good. And what does thermometer 3 say?
Thermometer 3 says 24.6 Celsius.
24.6 degrees Celsius. Thank you. Alright, so I stopped our timer. Even though this is still on, I stopped the timer so we can talk about this for a second. So what are we noticing? What's happening to our different lines of latitude? Which one's the hottest right now? Which line of latitude is our hottest? Guillermo? Why do you think the equator is the hottest right now? Because it's getting direct sunlight. Very good. That's a key word, direct sunlight. And what's our coldest right now? What is our coldest? Gracie? And what latitude line is that at? Good, 45 degrees south. And why do you think that's the coldest? Looking at this globe.
Because the sun
Good. So what we call this is indirect sunlight. It's not getting the sunlight. The sun's really not pointing at it. Very good. Okay. So we're going to look at our next. In 10 minutes, we'll be looking at it again. I'll start our timer, and we'll define our next word. So I keep throwing this word equator around. Equator, equator, equator. And we just found out that right now our equator is the hottest location on our globe. So your definition for equator is an imaginary line around the middle of a planet. Okay? So any planet, even Earth, is going to have an equator. The equator splits Earth and any other planet into equal halves. Okay? Into north and south. So, that's why if we look at our lines of latitude, we see that anything north of the equator has the line of latitude to degrees, and then it says north. So all this is saying is Phoenix is 33 degrees north of the equator. Okay? So it's 33 degrees, 33 lines of latitude degrees north of the equator. for our spot in the South Pacific Ocean is right here. This is right where that probe is on there. So anything below it is south of the equator. And that's why we say, we don't just say it's 45 degrees, it's 45 degrees south from the equator. So these lines of latitude are all basing their position from the start at 0 degrees, where the equator is located. Okay? Who here has ever heard of the country Ecuador? Where do we think Ecuador is located? What do you think, Devin?
0 degrees north and south.
Good. And why do you think Ecuador is located on 0 degrees north and south?
Because it has the word equa.
Yeah, it kind of has some of the equator in the word Ecuador, right? Good. So the equator is still a line of latitude, okay? It's still a horizontal line that goes across the earth, but it does split it into northern and southern halves. Because if we didn't have an equator and somebody said I was 33 degrees north, or they said I was 33 degrees line of latitude, well, you could be north or south. So we have that latitude line of the equator, so it splits it up into northern and southern hemispheres. Okay, so make sure you get that definition written down. Make sure you have a picture drawn. So when you're giving your explanations later, I expect you to be using all 4 of these vocabulary words. Okay, so who would like to come up and check our temperature probes next? Decrease? What do you think? Andrew, I see you pointing up. Which one do you think might go up? Well, why do you think that?
Because the light's been pointing there for a while.
Yeah, the light's been pointing there for about almost 10 minutes. Okay. So, do we think any of the temperatures are going to go down though? If the light's been pointing there for 10 minutes, are any of these temperatures going to decrease? See a few people shaking their heads. Latoria, what do you think? Okay, not directly pointing at the one in the South Pacific. We'll see. All right, so let's look at our temperature check at 10 minutes. So flip back to your data table on your front, and Marisa, will you read our thermometer number 1, please? Read thermometer number 2 while this one turns back on, okay?
Thermometer 2 is 36.
What does it say? We'll just read what it says right now.
36.2.
36.2 degrees Celsius. What's the number 1 say?
27.0.
27 degrees Celsius. And what does thermometer 3 say?
It says 25.0 Celsius.
25.0 degrees Celsius. Thank you. So it looks like all of the temperatures have increased a little bit. Okay? Looks like all the temperatures have increased a little bit. So which thermometer is still our hottest? Eric, which thermometer is still the hottest? And why do you think number 2 is still the hottest? Good, because you're seeing that the temperature is increasing. But why do you think the temperature is increasing? Can you speak up a little bit? I can't hear you. So if I can't hear you, then these people in the third row definitely can't hear you. Can you sit up and speak to the class? Because none of us can hear you right now. It sounds like you have a good answer, but we can't hear you. Okay, so the light has been on that spot for a while, right? Good. And which spot is our coldest, and why do we think it's still the coldest? Which thermometer is the coldest? Armando? Good. Thermometer 3 because the sun's barely hitting it. What we call indirect sunlight. Very good. Okay. Flip to your back. We'll get another 5 minutes. Our next word. In the place where the sun is getting where it's directly hitting the earth, where it's not at a low angle, what we're seeing already is that's going to be a warmer temperature. Okay. So we need to get somebody else to come up here and check our temperatures for our 15-minute mark. Damien, why don't you come up and check these? This is thermometer 1, 2, and 3. Okay, give me a second. Alright, so let's check our thermometer 1 at 15 minutes. What do we have?
Thermometer 1 says 27.2 degrees Celsius.
Okay, 27.2 degrees Celsius. So we went up a little bit.
Thermometer 2 says 36.8 Celsius.
36.8 degrees Celsius.
And thermometer 3 says 25.3 degrees Celsius.
25.3 degrees Celsius. So, let me just explain this. I can explain this for you so you can get a better idea of how we can think about the angle of isolation. We have direct sunlight at 0 degrees. So we have our angle of isolation is not low, right? We're getting direct sunlight, so we see that that's giving us a higher temperature. As our angles start to get lower, when we get to 33 degrees north latitude, our temperature drops to 27.2 degrees Celsius. And when we get even lower, down towards the bottom, at 45 degrees south latitude, look at our temperature. It's 11 degrees Celsius cooler than thermometer 2. Because it has such a lower angle, it's getting a lot less direct sunlight. Okay? And our last word. We always been throwing around this word temperature. Now, we're going to get a better definition of temperature later on in the year when we learn about energy. But for now, I just want you to know temperature is the degree of hotness or coldness of the environment. So it's either how hot or cold, when we're talking about climate, the environment is. And here's a fact. The lowest recorded temperature, so I think this is cooler than the highest recorded temperature. The lowest recorded temperature on Earth happened in Vostok, Antarctica. Negative 129 degrees Fahrenheit is the lowest temperature ever recorded. So the degree of coldness was super cold, right? The degree of coldness was 129 degrees below Fahrenheit. Right? So all we're measuring with these different latitude locations is the degree of how hot or cold something is. So we're seeing right now that the equator has a higher degree of temperature, of hotness, than the other two places. And the 45 degrees south latitude, it has the lowest degree of hotness between the three of our temperature probes. I want you guys to think back to our first unit on inquiry. What instrument do we use to measure temperature? What instrument do we use to measure temperature? Anna? Can you say the complete sentence?
The instrument we use to measure temperature is a thermometer.
Good, the thermometer. Alright, so make sure you guys are drawing a picture. So all of these probes, these are just fancy high-tech thermometers, okay? It's the same thermometer that we used in the beginning of the year when we did the finger diving into the graduated cylinders, into the beakers. It's the same technology as the thermometers if you go to the doctor's office and they put something in your ear, they put something in your mouth. It's finding out the degree of hotness or coldness of you, or we're finding the degree of hotness or coldness of the climate, of the environment. So take about 1 more minute, get your picture drawn in. Make sure you have your definition complete. You guys are doing a great job today, taking great notes. Last point. I think you guys are back in the lead with past points. You gotta make up that 1 point loss from last semester. Okay, who would like to be our final participant? Come up here and read the temperatures for the class. We'll just pull a stick. Pull a stick. I can't decide. Too many hands up. Andrea, come on up. Okay, Andrea. So you just need to read these temperatures out nice and loud, okay? Alright, Andrea, read thermometer number 1. 27.2 degrees Celsius. Good. Can you read thermometer 2? 36.6 degrees Celsius. Good. And 25.4 degrees Celsius. Okay, so make sure you have all of those down. And now we're going to have to analyze this data. So, with your table partners, there are 3 questions underneath your table of data, underneath your data table that we used. What you need to do, go check your predictions, okay? Talk about which thermometer increased the most in temperature. Then talk about which thermometer, oh, there's a typo. On number 2, I want you to write for number 2, where it says which thermometer's temperature increased, scratch that out and write decreased for number 2. Or for number 1, doesn't matter. One of them needs to say decreased. Or instead of then where it says highest, you need to say explain why you think this latitude had the coldest. Okay? So it might not necessarily, nothing really decreased, but you need to talk about the coldest for that number 2. So my mistake, you know I like making typos. You're laughing? Okay, again, so number 1, which temperature increased the most? And why do you think this latitude had the highest temperature? Number 2. The negative temperatures decrease, and which latitude had the coldest, not the highest. And then number 3. How do these differences in temperature at different latitudes affect Earth's climate? So kind of a higher level extension. You have to apply what you just learned. Okay? Try to use some of your vocabulary words when answering these questions. Okay? We will take 7 minutes for you to answer these 3 questions in temperature. What's the thermometer? And what was the hottest? So, let's talk about lines of latitude. Which line of latitude was the hottest, and why do you think that? Ron, we haven't heard from you today. Why don't you share out, please? Say it louder. Okay, explain why. Good. Perfect explanation. The equator had the highest temperature because it had direct sunlight. Okay? The angle of isolation was not low. The angle of isolation was high. It's getting direct sunlight. Okay? And number 2. What latitude line was the coldest? The latitude line was the coldest. Alan, what latitude line was the coldest? What's our degree of latitude though? What's our degrees of latitude? Celsius? (45 degrees Fahrenheit? We're talking about temperature when we talk about lines of latitude. South. Good. It's 45 degrees south of the equator, right? So in a complete sentence, tell us what the coldest latitude line was and why. You say it louder because that's a good answer. Say it loud so that everybody can hear you. Good. So the South Pacific, or the 45 degrees south latitude line, was the coldest because it's getting indirect sunlight. It's pointing indirectly at it, right? It wasn't getting as much as the equator. Okay? And we saw that Phoenix is in between, right? It was in between. So let's see how this affects climate. So flip to the back of your sheets, everybody. Oh, sorry, I forgot to answer question 3. What's question 3? How does it affect climate? Gracie's doing something crazy with her hand. I don't want her to get hurt, so go ahead.
The closer you are to the equator, the higher the temperature. The farther you are to the equator, the colder you get.
Good. So, based on our lines of latitude and the angle of isolation, the closer you are to the equator, the warmer the temperature should be. And the farther you are away from the equator, the colder you're going to be. So this is going to cause different climates. So if you flip to the back and look at that circle of the Earth with the blanks, what I want you to do, the blank lines are telling you the climate zones. And then over on the left, you need to write the degrees of latitude next to those lines outside your Earth. So, we'll start at the top. So you're just going to fill in the blanks and write the latitude lines over to the left. Our top climate zone of the Earth is called polar zone. Okay? Polar zone is 66.5 degrees north and 66.5 degrees south of the equator. So this is going to be very cold. And I'll go a little bit more into that on the next slide. we have our two green. This is where we live. We live in the temperate zone, right? We look, Phoenix is at 33 degrees north. The temperate zone goes from 23.5 degrees north to 66.5 degrees north, and 23.5 degrees south to 66.5 degrees south. So the temperate zone, they're not going to get as much indirect sunlight as the polar zone. Okay? So where Santa Claus lives and where penguins usually live, they usually live in the polar zones where it's really cold. We live below that. We live in the temperate zones. So the temperature is, besides that we live in Phoenix, which is a different story, which we'll talk about at some point, but usually the temperature is mild. And the biggest thing about temperate zones, everybody, we have 4 seasons. Okay? We have 4 distinct seasons in the temperate zones. Okay? And then from 0 degrees at the equator to 23.5 degrees north and 23.5 degrees south, we have the tropics. So anytime you ever hear of people going to tropical islands or going to the tropics, this is where it's always warm, it's always nice, and there's not much change in the season. The distinct thing about the tropic zone, however, is that they're going to get a lot of rain. So they're going to get a decent amount of rain in the tropic zone. Okay? So if we think through our globe over here, the direct sunlight's going to hit the tropics. Our indirect sunlight's going to hit the temperate, and then more indirect sunlight's going to hit the polar where it's really cold. Alright? So we see the farther we get away from the equator, the climate is going to change because of the amount of sunlight. So just to give you a little better description on the next page, you have that little box over on the right side where you can fill in a little better definitions of these. Okay, so the box on the right side with the lines, you can just kind of talk about the climate. So the tropic zone, which is in the middle, again, 23.5 degrees north and south. It's warm, it's hot, and it's moist. This area of the world is going to be getting the most direct sunlight. The angle of isolation is very high here. Okay? It's going to be usually tilted more towards the sun. Now on the opposite of that, we have our polar zone, which is at the top and bottom of Earth. Polar zone is 66.5 degrees north and south, and is closest to the pole. So polar bears, right? Polar bears live in the polar zones. That's how they have their name. They live in that really cold weather. So the biggest thing about the polar zone, they have a low angle of radiation or a low angle of insolation, and it's always going to be pretty cold there. So our lowest recorded temperature in Antarctica that we talked about before, that's in the polar zone, because the angle of isolation is very, very low. Whoops. See, I always have typos. Temperate zone. Temperate zones are located between the tropic and polar zones. So they're located between 23.5 degrees and 66.5 degrees north and south. Okay? This is a medium temperature climate, and the United States falls directly into this temperate zone. And we have changes in season, right? The biggest thing about the temperate zones, we have big changes in season. So in Phoenix, there's a huge difference in temperature between the summer and winter. The summer gets up to 110 degrees. In the winter, we get down into the 40s and 50s. So that's almost a 70-degree change in temperature. Okay? So that means in the summer we're getting a lot more direct sunlight. In the winter we're not getting as much sunlight. So if you look on a globe, you look on a map, cities that are located in the tropic zones are going to be warm. Cities located in the temperate zones, they're going to have a lot of different seasons. So they might be warm at some points, they'll be colder at other points. In the polar regions, they're going to be pretty much cold all year round. Okay, so for the last 8 minutes or so, I'm going to pass out exit tickets. And you're going to really need to use your notes. Use what you have learned to answer the questions on the board. If you need to get up, to read this because it shows the angles of latitude, you may do so quietly. Don't disturb anybody else. Okay? So there's different letters on here. And it's asking you what letters represent the hottest places, what letters represent the coldest places, and why. And then number 3 is asking you why does latitude affect climate around the world. Okay? So get these exit tickets out. Work silently by yourself. Make sure your names are on these.